Hello everyone. This is one more interesting question. With this, I will solve one more question. This question I will also solve. And both of these questions came in GATE 2025 Geophysics exam. Okay. Why I have taken these two questions? Because these two questions are relevant with geology. Okay. And this question may repeat in future. Sense of asking is maybe different, but concept is very important for this question. Okay, and this is a purely concept based question. Okay, and it is also a structural geology question. Okay, so and one more thing is that if we read this question, you think that this is our right answer, late boundary, because we have seen like this now. So we are considering it as a mid-oceanic ridge or as a means collision, continental continental plate collision. We may think in that way. Okay, so all four options are very interesting. Okay, so first we will learn the concept, and one by one we will delineate the options also, and why these options are wrong we will also understand that. Okay, and if you have any other question apart from this, I and you can ask me anytime. Okay, and ask from the system from where you are learning. Okay, because if you want to understand the things, you asking question is very important. Okay, so now and okay, now let us start this question. In this question, the following figure shows a region in which the rocks in area A, B, and C follows Hooke's law. Both the rocks A, B, and C means all three are rocks which are following Hooke's law. Either these rocks are of same material or not, they are not mentioned. We'll read further. And are subjected to same stress. All three rocks we are applying same stress, same amount of stress. Okay, whatever we are applying. Okay, okay. Now the second condition is, now the main line is B exhibits low strain than both A and C. Okay, means B have a low strain. Okay, now what can we infer about the nature of B? Okay, we have to tell the nature of the B. Okay, okay. First, we will learn what is Hooke's law. Okay, Hooke's law. Hooke's law tell that stress is proportional to strain. Stress is proportional to strain, and this proportional sign is have a constant. We call it as a Young modulus. Okay, and this Young modulus, what it measure? It measure stiffness or resistance of elastic deformation. Stiffness or resistance means how the material is resisting. Okay, we apply. Okay, I will explain more. Okay, under stress. Okay, suppose if we have a body and we are applying force on it, okay, now the force we apply on this area, we call it as a stress. Stress is force per unit area, and this is strain is when we apply force about this area. After that, what are the changes in that area, or in length? Okay, so suppose this is our change in, suppose this is this block change in length. Okay, so change in length upon total length. Okay, now if we want to calculate this Young modulus E. So our E will come sigma F upon A. This is L by del L. This is our Young modulus. Okay. So now we will make one more graph for this. Suppose this is our stress and this is our strain. Okay. In Hukla, if we apply stress, we are getting a constantly increasing in both the things are proportional, both the things increase equally. Okay. Okay. Suppose this much stress we have applied. So our strain is this much. Okay. Now in our question it is mentioned that same stress is applied. Means stress that we apply is same. Okay, suppose this much stress we are applying. Okay. But A, B and C both B exhibit low strain. Means B exhibit low strain. Its graph is like this. As comparison, it is B. Okay. Because strain is low, na? Stress is same. Okay. This is the value for strain. Okay, for A and B, suppose both are the same material, okay, or different material. Its graph is above these two, this B, okay, little low angle, okay, it is increasing. Make it 45 or something. Okay, now in B we are getting low strain, and in A and C we are getting high strain A as comparison to B. Okay. Now we are coming to our options so that we can, whatever we have learned till now, we can find out our answer and also learn these options. Okay. Now in first option, B is a part of plate boundary. B is a part of plate boundary. Okay. B is not a part of boundary. Why I am telling this? Because at plate boundary, okay, heat flow is more. Heat flow or temperature and pressure is more, or deformation is also high. If deformation is high, it means stress is more at boundaries. Stress is more at boundaries. So it is not a plate boundary. B is not a plate boundary because we have a low strain. If we have a more stress, we get more strain. So this rock should have more strain as comparison to A and C if it is a plate boundary. So it is not a plate boundary. Okay, that's why this option is wrong, and I have corrected. Okay. Now in option B, B has higher heat flow value compared to A and C. Okay, if I already mentioned, okay, if it has a higher heat flow, okay, it means temperature and pressure is also increasing in that body. Okay, then pressure and temperature increases when we are applying some forces, na? Like stress. If we are applying from, okay, load we are applying, then we are getting this stress and uh, heat flow. It means temperature and pressure, and the result we will get in heat flow. Okay, it is not a case because in our option there, in our question they are mentioning low strain. For low strain we need lower heat flow. Lower heat flow instead of higher heat flow. Okay. Now in option C, B is made up of rock of low density compared to A and C. Okay. If we look at our formula, sigma is proportional to stress is proportional to strain. In this we are not using any density, okay, in our formula. Okay. Okay. With respect to the question, okay. Now apart from question, okay, suppose we have a two material, okay. one is having high density and one is having low density. Okay, the material which is having high density, okay, it means its particles are tightly bound. Material is highly, means particles are very tightly arranged, okay. But in, if the density is less, so particles are not that arranged well. This concept is also contradictory, okay. But for understanding this option, I'm just saying this, okay, in general prospect, okay. So now, if we have a high density material, okay, if we apply stress on it, okay, it will resist that stress, okay. But if we apply the stress on a low density material, okay, it will break, okay. If it break, it means it has a high strain instead of low strain, okay. We are applying same force, okay, both the bodies, okay. Only the density is vary, okay. Only the density is vary. Here we have a low, here we have a high. The higher one is having low strain, okay. So it means B is made up of rock of low density. No, it is made up of higher density. That's why after applying the same stress on all the rock A, B, and C, B behave low strain as comparison to A and C. This option is also wrong. D option is B is made up of rock that have higher strength, okay, that have higher strength compared to A and C. If density is high, its strength is also higher. Now, if we understand this, okay, after now we will club all the options, okay, and try to visualize the things, okay. B is having a high strength rock, okay, because we are receiving a, after applying a stress, we are getting a low strain, okay. It means it has a higher strength, and higher strength will come from higher density. It means from A and C, B have a higher density material. And if we apply heats to all the rocks, B will, in B we will means uh, if we apply heat now to all the three rocks, okay, so there is a low heat flow in B because it need time as comparison to other, because other material are less density material, okay. And B is not a part of plate boundary because we need a, for plate boundary, all the three plate boundaries have a higher temperature and pressures, okay. Means temperature pressures are higher as comparison to within the plates, okay, because these are the where we are getting new plates and where we are getting subduction zones, okay, and strike slip also, okay. So in this way we will approach these questions, okay, and this question itself is a very interesting question, okay. So keep learning in this way, okay. So now in the next question, so now in our next question, it is a basic question. I will take only 1 minute, okay, to solve, tell us. Okay, in a, so in this question we have a, in a systematic line P shows 1D geothermal profile. Okay, this is our geothermal profile. Okay, that P represent. Okay, okay. If the heat flow at base of mantle increase, this is our mantle. Suppose this is our core part. Okay, so heat flow is increase. We increase heat here. Okay, so if we come from here to here, our heat will get decreased. Okay, suppose this is like this. Here we are getting heat, here we are getting depth. So now in this question, in the systematic line P shows, okay, in this question, in the systematic line P shows 1D geothermal profile. Okay, we are having a geothermal profile. Okay, okay, with depth how temperature is behaving. Okay, so if the heat flow at the base of mantle increase, okay, at the base of mantle heat is increasing. Okay, okay, suppose we are a temperature value. Okay, here we are having a 5, here we are having a 10, and here we are having a 5, 10, 15, suppose, for understanding. Okay, so now if we increase our heat, temperatures are also increasing here, here, and here. Suppose now it is now 10, it is now 15, it is now 20 after increasing the heat. Okay, so now our this P line will move toward our Q. It is moving toward our Q because our temperature is getting raised with the depth. So our right option is this one. Okay. Now, if you have any other question apart from this, you can ask me, okay, and ask from the system also from where you are learning, okay. And if you have any query, okay, you can ask, okay. And try to share this video with your friends so that they can also get benefits, and try to discuss among each other, and grab the opportunity. Okay, don't wait for the opportunity. Okay, be ready for the opportunity. Okay, opportunity will come. Thank you. Hope you learned something from this video.